Okay, what we have now on the screen is a triangle, simple triangle, 3, 4, 5 on the sides, and the triangles, if you add them up, you will get exactly 180 degrees. Okay, 180 degrees. So this means that there's no misclosure, a perfect traverse, which don't normally happens when we're actually doing our work. So let's look now. When we do our traverse, when we do the work, I mean, we observe angles, we observe distances. Okay, so random errors in these two measurements will be there, unavoidable. We cannot just ignore them. So that's how we need to know ways of dealing with these errors so that we can minimize their effect in our final answer. Okay, that is a figure of a traverse with only angular error. So if you add up all the angles, the three angles there, I think you get about 181 degrees, which means that we have a 1 degree error. But somehow the distances are okay. It's exactly 3, 4, 5, somehow or other. Okay, might not happen this way, but it's just for illustration purposes. Then we might also have, in another instance, with distance error. Okay, angles are okay, they're all add up to 180, but the distance, that one is a bit off, should be 5 or 5.2. That means we are off, we are 0.2 meter too long. So that's, again, something which could, or which I would say probably not, if it happens, maybe 1 in a million. So anyway, the most common thing that we will be getting at the end of our traverse work will be both angular and distance error. So it might look something like this. Distances are not exactly what they should be, and the angles here, if you add up, they're not 180. So it's errors in both measurements, so the random errors. Okay, so let's do one example and see how we determine the errors and how do we treat them, both of the errors. I think we're going to concentrate on angle first. Okay, angular misclosure. Okay, similar to any surveying method, there'll be errors, and we call them misclosures. Okay, and the first thing you have to do is, when you got any errors or misclosure, you have to find out whether they're acceptable. If they're within limits, then you can proceed with your calculation. If they're not, you highly likely have to re-observe the angles. Okay, so we're going to distribute the errors equally, okay, to each of the angles in the traverse leg. And acceptable limit, as far as normal engineering, general engineering application, we're going to use a standard for what we call the second class traverse, which among other things says the maximum angular misclosure is 2 minutes 30 seconds. Okay, so that's a number you have to remember, 2 minutes 30 seconds. So how do we do that? How do we find out? Okay, let's do one example. Okay, now we have to compare the angle that we observed, the sum of all the angle that we observed, against the theoretical value. Okay, so if you observe external angle, That's basically what you should get if there's no error. Okay, the n represents the number of angle, and for internal angle, so that's the simple formula that you can apply. So you're going to compare the value that you obtain here, let's say for an external angle, wherever you obtain here, against the value of that, the total angle value, the total value of the angles that you have observed. Okay, and then I've got an example on the next page. Okay, a traverse that contains from A, B, C, D, F. Okay, we have 6 points in there, 6 stations, and given the angle, internal angle, which means that the work was done anti-clockwise. You're given a arbitrary north, which means that this value there is an arbitrary bearing. Okay, let's do the first thing. It says determine the angular misclosure for the bus traverse and calculate the correct final angle. Okay, so first thing first, list down all the observed angle and sum them. Okay, so in this case it is 720, 0 to 0, 0. So 720 degrees, 2 minutes and 0, 0 second. Okay, and the required angle using the formula that we just mentioned, 2n minus 4 times 90, that's 720. So which means the theoretical value is 720, observed value is 720, 0 to 0, 0. That means we have an error of 2 minutes plus 2 minutes. We are 2 minutes extra more. Okay, we are 2 minutes too much. Okay, now what we have to do then? We have to do correction or adjustment. So 2 minutes, because our error is positive, so therefore the correction will be negative. So it's negative 2 minutes divided by 6. 6 represent the number of angle. Okay, A to F, 6 angles. So which means that we have to correct each angle minus 20 seconds. So that's what we're doing here. Okay, we're going to correct all angle, 20 seconds, and we will obtain that. Okay, and finally, when you've done with all the correction, you get all the adjusted angle, you got to sum them. Okay? Sum the angle, and that value and that value should be equal. Okay, so that is how this is the way, or the method. How do we apply? How we apply a correction to the angles that we observe. Okay, the important thing to remember is that this misclosure must be less than 0 to 30 seconds. Okay? If it's more than 0 minute, as 2 minutes 30 seconds, you have to re-observe. You have to re-observe, I don't know, a few angles in there, just to find out which one of the angles contains huge errors. Okay, so that's about angle correction, treating random errors in the angle measurement. Okay, for a link traverse, you compare, okay, there are 2 ways of doing this. You compare the computed final forward bearing, okay, if you're using a bearing, if you want to look at the bearing rather than the angle, you compare that against the known final bearing. Okay, so when you start your work, you got to start from a known station with a back bearing, When you finish your work, you have to finish at the known station as well with a known forward bearing. So you got to compare the computed final forward against the known final forward. That will be your angular misclosure. Or if you like, if you don't want to use bearing initially, if you like to use the angle, you can do so. You just look at the computed final forward bearing, which is that value there, minus initial back bearing, which is here, okay, plus m times 180, where m, okay, could be equals to n plus 1 or n minus 1. N is the number of angles observed. Okay, so a bit long-winded compared to the first approach, compared to that one there. This is a bit straightforward. Okay, a bit long-winded, the second one here. But then you're free to choose. They're both valid. Okay, so m, this value of m, you have to try and error. You can either use n plus 1 or n minus 1. You have to look at the numbers and assess them. I personally would just use the first one because it's quite easy and quite straightforward to use, and the calculations are not that difficult. Okay, now let's look at one example here, a linked traverse now. Okay, a linked traverse. Okay, you're given bearing A to B, bearing 4 to X, and bearing A to B, and bearing X to Y. You're given there. You're given all the angles, angle at A, 1, 2, 3, 4. Okay, so you're going to use the angle now to calculate what the angle misclosure. Okay? Then calculate the corrected final values. Okay, I would, let's make this as your, what should we say, as your exercise to do on your own, maybe. Okay, your exercise to do on your own. Now I will post the answer in the e-learning. Okay, so have a go at that and see whether you can do it. Okay. All right. Next, we'll be moving on to distances now. So we have dealt with the angles. Okay, we have looked at how the angles are corrected. Now we're going to move on to how do we take care of the errors in distances that we measure. Okay, so we don't actually correct the distances, but we correct what we call latitudes and departures, which are in a sense basically latitude mean difference in northing, delta n, and departure simply means delta e. Okay, difference in these things. Okay, we need them to do our coordinate calculation. Okay, so difference in latitude simply refers to difference in northing, and departure simply means difference in easting.
انضم معنا الآن واشترك بالقناة ليصلك كل جديد. YSAG، معا نحو مستقبل مشرق.